Hey everybody, this is Mr. Longo here, and we are going to talk about absolute value equations on a graph. So, graphing absolute value equations, in order to see it better for the first time, we're going to use some t-tables, and you are not going to need to do this for a quiz or a test or anything like that. It's just to help you see what an absolute value graph looks like, and we're also going to talk about some transformations. So, what is the absolute value of x? Well, to start, let's just pick a few values of x and see what we get. So, what's the absolute value of a negative 2? 2. What's the absolute value of 0? 0. What's the absolute value of a positive 2? Still positive 2. So, if we were to graph those three coordinates, we would have negative 2, 2. We would have 0, 0, and a positive 2, 2. So the 0 is pretty much where it changes from positive to negative, and absolute value graphs are going to look like these. So we have an absolute value, and we're going to have a V. Now let's talk about what happens when you put a negative sign in front of absolute value. As we talked about before in a previous video, if there's a negative sign in front of an absolute value, you do not distribute. So, what is the absolute value of a negative 2? 2, but there's a negative in front, so it's negative 2. The absolute value of 0 is 0, and luckily there's no such thing as a positive or negative 0. And the absolute value of 2 is 2, but again, the negative is still out front, so that's going to give you a negative 2. So, what a negative sign in front does, it basically flips it over the x-axis. So negative 2, 0, 0, and a positive 2, negative 2. So the graph looks the exact same, but it's upside down. And that's going to do it to all different kinds of graphs throughout the course of the rest of this class. We're going to be turning parabolas upside down and square roots upside down. All sorts of different graphs are going to be flipped upside down when there is a negative in front. Okay? Now let's talk about the absolute value of x, but we're going to add 2 to the end. So the absolute value of a negative 2 is 2 plus 2 is 4. The absolute value of 0 is 0 plus 2 is 2. The absolute value of a 2 is 2 plus 2 is still 4. So we'll plot those: negative 2, 4, 0, 2, and 2, 4. And what you can see happened is we just shifted the V up by 2 units. Everything got shifted up 2 places. So when you have a number that's on the outside, that is a vertical shift. If that said minus 2, then we would be shifting down 2 units, okay? And again, the negative in front, that means we flip upside down. More specifically, we reflect over the x-axis. Okay, let's continue with a couple of more. What happens if we put a plus or a minus 2 on the inside of the absolute value? Well, that's going to be negative 2 plus 2 is 0, and the absolute value is 0. 0 plus 2 is 2, the absolute value of 2 is 2. And 2 plus 2 is 4, and the absolute value of 4 is 4. So now we need to go backwards a little bit. I'm going to throw in one more coordinate here, and let's just say a negative 4. Negative 4 plus 2 is a negative 2, and that's going to give us the absolute value is going to be 2. Okay, so I want to show you what just happened here. So we have our negative 2, 0. We have our 0, 2. We have our 2, 4. And then I went backwards and did a negative 4, 2. So if you look at all the other graphs we did, the vertex was on the y-intercept. That's because we didn't move it left or right. If you have something inside the absolute value, or when we start working with other types of equations, inside parentheses, it's going to shift it left and right. And as you can see, it shifted it in the opposite direction of what you probably thought. You probably thought by adding 2, we're going to go to the right, but what we did is we added 2 to the x value, so what it really does is shift it to the left, okay, because a negative 2 plus 2 gave you 0, so we had to move left to bring you back to the 0. So that's how that works, okay? So just wanted to show you, so inside, so if you have something inside, that is a horizontal shift. And this type of vocabulary is going to come up in all sorts of different chapters. That's why I'm taking the opportunity to show you a little bit now. So for this next one, what we're going to do is we're going to multiply by 2. So if the absolute value of a negative 2 is 2 times 2 is 4, and the absolute value of 0 is 0 times 2 is still 0, and the absolute value of 2 is 2 times 2 is still 4, when we graph this, we're going to have our 0, 0, but we're going to have our 2, 4, and we're going to have our negative 2, 4. And what happened was this graph got stretched vertically. Okay, so when you multiply it by a number bigger than 1, that is a vertical stretch. Now, you're going to hear the terminology narrow. It is more of a narrow V, but it's not because we squished it horizontally. It's because we stretched it vertically much faster. Okay? And the opposite of that would be a vertical shrink, or it's still a vertical stretch. It's just stretched or shrunken because it's a fraction. So that would be negative 2. The absolute value of a negative 2 is 2, but half of that is 1. And of course, you can figure that this is going to be 1, 0, 1. Now, if we were to go to negative 2, comma 1, and then of course 0, 0, and 2, comma 1, this V looks wider. Again, it's because we flattened it. We made it shrink vertically. Now, one of the things that you'll notice is that the slope comes into play here. This is basically a slope of 2 over 1. You go up 2, right 1, up 2, right 1. But since it's absolute value, you also go up 2, left 1, up 2, left 1. And the 1/2 works as well. Up 1 over 2. Up 1, left 2. So it will work in terms of slope. You just have to remember it's going to be opening up or opening down, depending on if it's positive or negative. So I wanted to take a little bit of time to introduce all these different stretches and types of graph, all the different transformations, because we're going to be doing that a lot throughout the course of this class. So again, I said you do not need to make a t-table to graph these. You can if you really, really want to, but let's talk about what happened. Remember, this is a vertical shift, which means everything started 3 above where it did. And the inside was a horizontal shift in the opposite direction of what you think. So our starting point is going to be at a positive 2 because it's the opposite direction. And then it's going to start 3 higher than what you would normally start. So we're going to start up 3. But that's just known as our vertex. Our vertex is the opposite of the inside of our absolute value and our outside. So we went up 3 and we went right 2. So remember, left and right is our x-coordinate and up and down is our y-coordinate. So we can start out by just plotting 2, 3. Now we're going to use our slope. It's a positive 1. So we're just going to go up 1 over 1, up 1 over 1, up 1 left 1, up 1 left 1 because of the absolute value. So there you have it. It's done. The second one, there's no horizontal shift. So we did not go right or left at all. But we went down 3 because that's our vertical shift. So our vertex is going to start at 0, negative 3. But now we look, we have a negative sign. So this is going to go down. And the slope is 1. So it's just down 1 over 1, down 1 over 1, down 1, right 1, down 1, right 1. So it's just the same thing as what we were looking at earlier, except for we just started 3 below. The last one's got a whole bunch of different transformations for you. So the first thing we have is our 1 unit to the right. So we're going to start 1 unit to the right. And this is our vertical shift, so this is 5 units up. So our vertex is where we do our vertical and horizontal shifts together. It's 1 to the right and 5 up, so we're going to start at 1, 5. But now we need to use our slope of a -3, or our multiplier of a -3. Remember, the negative means it's going to be flipped upside down, and the 3 is going to be how much faster it rises or shrinks, or rises or falls vertically because of the vertical stretch. So we're going to go down 1, 2, 3 units over 1. Down 1, 2, 3 more units over 1. Down 1, 2, 3 over 1. And as you can see, it is a much faster falling absolute value graph because it's negative and we're stretching it by a scale of 3. All right, so that's it for graphing absolute value equations. This is Longo and I'm out. See you, bye.